In this video, I'll be solving third part of second problem of UPSC Civil Services Mains 2020 Statistics Paper 1. So let theta is greater than 0 be the unknown parameter and x1, x2 and so on xn be a random sample from the distribution with probability distribution function as 2x by theta square when x is in between 0 to theta. So we need to find maximum likelihood estimator of theta and its mean squared error MSE. So first, like, we are having IID sample with PDF fx of theta is 2x by theta square and 0 less than x less than or equal to theta, where theta is greater than 0. So the likelihood is I is equals to 1 to n 2xi by theta square, so which is product of I is equals to 1 to n 2 times xi into theta to the power minus 2n, provided this theta is at least greater than or equal to this nth order statistic. So that means so this factor theta to the power minus 2n, so that is always decreasing in theta. So the likelihood is maximized at the smallest admissible value of this theta. So that means this theta hat MLE would be the smallest possible value, which is nothing but the nth order statistic. So the CDF of the single observation here, so fx would be x square by theta square for 0 less than or equal to x less than or equal to theta. So the CDF of maximum, so maximum order statistic is fxn of t, so that means everything should be less than that. So that means it will just be t square by theta square whole to the power of n, which is t to the power 2n by theta to the power 2n, where 0 less than or equal to t less than or equal to theta. So therefore the density would be fx of n theta, so that will just be 2n into t to the power 2n minus 1 e to theta to the power 2n, where 0 less than or equal to t less than or equal to theta. So expectation of x of n will just be 0 to theta 2n into t to the power n minus 1 2n minus 1 theta to the power 2n into t dt, so which is 2n by theta to the power 2n theta to the power 2n plus 1 by 2n plus 1, which is 2n by 2n plus 1 theta. And in the similar way, expectation of the square of this thing is 0 to theta t square 2n t to the power 2n minus 1 theta to the power tn dt, so which is 2n by theta to the power 2n into t to the power 2n plus 2 by 2n plus 2, which is n by n plus 1 into theta square. So therefore variance of xn will be expectation of xn square minus expectation of the nth order statistic whole square. So that is nothing but theta square into n by n plus 1 minus 4n square by 2n plus 1 whole square. So that is nothing but theta square into n into 2n plus 1 whole square minus 4n square into n plus 1 by n plus 1 into 2n plus 1 whole square. So that is nothing but theta square into n into 4n square plus 4n plus 1 minus 4n cube minus 4n square. So here as well, if I multiply, this is 4n cube plus 4n square plus n minus this thing by n plus 1 into 2n plus 1 whole square. So this will get cancelled. So the variance of the nth order statistic is nothing but theta square into n by n plus 1 into 2n plus 1 whole square. So the bias of the maximum likelihood is bias of this estimator theta hat, which is expectation of theta hat minus this theta. So that is nothing but 2n by 2n plus 1 theta minus theta, which is minus theta by 2n plus 1. So that means like bias square is theta square by 2n plus 1 whole square. So the mean squared error MSE of theta hat will be variance of theta hat plus the bias square. So variance of theta hat, we got it as theta square into n by n plus 1 into 2n plus 1 whole square plus theta square by 2n plus 1 whole square. So that is nothing but theta square by 2n plus 1 whole square n plus 1 by n plus 1, which is nothing but theta square by n plus 1 into 2n plus 1. So that would be the MSE of theta hat MLE, where our theta hat MLE, we got it as the nth order statistic. So that is the MSc and the MLE, MSE of the MLE, and that's what we are asked to find in the question. So that's it for this video. We'll meet in the next video.